So welcome, this is CAIE paper, May June 2007, M1 paper. We shall try to solve all the questions. It says a particle is sliding up the plane. The initial velocity is 2.5, final velocity is 1.5. So let me write that one. Final velocity is 1.5 and the distance from A to B is 4 meters. So distance is equal to 4 meters. Is asking what is the deceleration. So A equal to question mark. So what am I going to do? I am going to use V square is equal to U square plus 2AS. So V is 1.5 square is equal to 2.5 square plus 2 times A times S is 4. So from there I get the value of A, which is 1.5 square minus 2.5 square by 2 times 4. So it becomes negative 0.5 meter per second square. So but it has been asked deceleration. So deceleration is equal to positive 0.5 meter per second square. Next, find the value of alpha. So for this, only one simple formula we have to use. Forward force minus backward force is equal to MA. Backward force is equal to MA. Forward force, because nothing is being pulled, minus 0, minus backward force will be mg sine alpha along an inclined plane is equal to MA. So from there, M and M gets cancelled. So acceleration is minus g sine alpha. So acceleration we got minus 0.5 is equal to minus 10 sine alpha. So sine alpha is equal to 0.5 by 10. So alpha is equal to sine inverse of 0.05. Take the calculator and do that one. It becomes 2.9 degrees. That's going to be the answer for the first one. Now second one. Two forces of equal magnitude 8 newtons acts on a point OA and OB. The angle between them is theta. The resultant of the two forces is 9 in the direction of OA. In the direction of OA, find the value of theta. So this 8 newtons, this one. So let me resolve that one into two components, 8 cos theta, and the vertical will be 8 sine theta. So now total the horizontal forces is nothing but what? 8 plus 8 cos theta. 8 plus 8 cos theta, that should be equal to the total component of the forces is 9. From there 8 cos theta is equal to 1, cos theta is equal to 1 upon 8, theta is equal to cos inverse 1 upon 8. Pull the calculator, shift cos inverse 1 divided by 8 should be giving you 82.8 degrees. So theta is equal to 82.8 degrees. Find the magnitude of the resultant of the forces. He is asking us to find the magnitude of the resultant of the forces. So we know that horizontal force, which is along x-axis, is 9 newtons. That's okay. Now along vertical one, we have vertical one, we can see 8 sine theta. 8 sine theta, so which is equal to 8 times sine 82.8 degrees. So my resultant will be equal to square root of x square plus y square. This is y. So which will be 9 square plus 8 sine 52.8 whole square. So I pull the calculator, 9 square plus 8 times sine of that answer whole square. So when I do that one in the calculator, I'm quickly doing that one in the calculator, I should be getting the answer as 12 newtons. That's going to be the answer. Question number 3. A car travels along a straight horizontal road with an increasing speed until it reaches a maximum speed of 30 meters per second. The speed is 30 meters per second. The resistance of the motion is equal to R newtons and the power is 18 kilowatt. Find the R. So same, forward force minus backward force is equal to MA. Forward force will be power by velocity minus backward force is resistance R is equal to MA. So what is a MA? But what is he telling that? is increasing speed until it reaches like a maximum speed, then it's a constant speed. Constant speed means should be equal to 0. Acceleration should be equal to 0. Once it reaches the maximum speed of 30, there is no what is this acceleration at all. The resistance in motion is constant and there is no acceleration. So therefore ma should be equal to 0. So power is 18,000 divided by velocity is 30 minus r. This is equal to 0. From there r is equal to 600 newtons. So once it is traveling with the maximum speed, it continues to maintain the maximum speed. In that case, there will be no acceleration. So therefore, I have considered acceleration as equal to 0. Now, given that the car has a mass 1200, find its acceleration at the instant when its speed is 20. So in this case, now again, I'm going to use the same thing, forward force minus backward force is equal to ma, but this time the speed is now at 20 and it is still increasing. At that particular instant, what is the acceleration is being asked. So forward force is power by the velocity, which was 20, minus backward forces resistance is 100, ma 1200 times a. From here a I get it as 0.25 meter per second square. Question number 4. Two particles P and Q of masses 0.6 kg and 0.2 kg respectively are attached to the lengths of an inextensible string which passes over a smooth fixed peg. The particles are held at rest with the string at taut. Both the particles are a height of 0.9 meters. The system is released. The particles move vertically. Calculate the acceleration and the tension before P reaches the ground. So P is 0.6 kgs. So let me draw that one, straight line, 0.6 g, whereas Q is 0.2 g. Tension upwards towards the pulley. Now P comes down and Q goes up. So the same concept again, see, we are using the third sum with the same formula. Forward force minus backward force is equal to ma. So my forward force in case of P will be, because it is coming down, 0.6 g. Backward force is tension is equal to 0.6 a. In case of Q, it's going up. Tension is a forward force. 0.2 g is the backward force is equal to 0.2 a. Solve these two equations. Tension gets cancelled. 0.4 g is equal to 0.8 a is equal to 5 meter per second square. Substitute that a in this one. Tension minus 0.2 g is 10 is equal to 0.2 times 5. So tension is equal to 3 newtons. So I got tension. So tension has been got, acceleration also has been got. Okay, so that's the first part. Second part, the time taken for P to reach the ground. So what was the distance? The distance is 0.9 meters. Okay, and so distance is 0.9 meters. Its initial velocity is 0. Acceleration just now we got 5.5 meter per second square. So what's the time? S is equal to ut plus half at square. Time we don't know. So 0.9 is equal to 0 times time plus 1 upon 2 times 5 times t square. From there I get the value of t as 0.6 seconds. That's the answer. Question number 5. A lorry of mass 12,500 kgs travels along a straight road AB and a straight inclined plane BC. BC is 500 meters. Speeds at A, B, C are given. This is at A, this is at B, this is at C. The work done against the resistance of the motion as traveled from A to B is 5000 joules. Find the work done by the driving force, as it travels from A to B. So A to B. So we have to use TWD is equal to delta KE plus delta PE plus WDF. What is all this? TWD means total work done. WDF, work done against friction. work done against friction. So we have to find TWD. What is delta KE? Delta KE means change in kinetic energy, final kinetic energy minus initial kinetic energy. Initial kinetic energy. Delta PE. What is delta PE? Final potential energy minus initial potential energy. So total work done has to be calculated. So let us do step by step. Total work done has to be calculated. Delta K, final kinetic energy, half times 1000. What is the weight? 12,500. 12,500 times velocity from A to B. We are calculating A to B, so 25 square. Minus initial kinetic energy, 12,500 times 17 square. Then delta P. Delta P will be 0 because it is moving on the straight line. There is no change in the potential energy. Then work done against the friction. What is the work done against the friction? It has been given in the question as 5,000. So plus 5,000. So when I simplify that, I will be getting 7,100 kilojoules. That's going to be the total work done. Now coming to the second part. As the lorry moves from B to C, the resistance of the motion is 4,800 newtons. The work done by the driving force is 3,300 kilojoules. Find the height about this one. So what is the height he is asking us to find it out, as it is going from B to C. So from B to C, same formula. So what I can do is pull this one, let's make it small. This one was the first part, we will leave it there. I am going to use the same formula. Total work done. Total work done is nothing but how much it is? 3,300 kilojoules. 000 is equal to delta KE 1 upon 2, 12,500 times 17 square final minus initial 12,500 times initial is 25 square, because I'm talking about B to C. So this is at C, this is at B. Then I go for changing the potential energy, final potential energy. So what is the final potential energy? So what am I going to do? I am going to draw a straight line if this height is h. So final potential energy is m, g is 10 mgh. I don't know, minus initial potential energy, I take it as 0 because it is at the level ground B. So I can write it out over here. This is at C, this is at B. Then work done against the friction. What was the work done against the friction? He has given it as plus 4,800. Now I have to simplify this and get the value of h. So directly I write it at 12,500 times g is 10 times h is equal to 33,00000 minus 4,800 minus 1 upon 2 times 12,500 times 17 square plus 1 upon 2 times 12,500 times 25 square. So let me pull that by a calculator. 3 zeros followed by 2 zeros minus 4,800 minus 0.5 times 12,500 times 17 square minus 0.5 times 12,500 times 25 square divided by, if I bring this this one also over here, divided by 12530 zeros. This should be giving me 24 meters. So h is equal to 24 meters. That's going to be the answer. Question number 6. A particle P starts from rest, particle A, and travels in a straight line, coming to a rest after 10 seconds. The velocity time graph is given. The velocity is given by this formula. Find the greatest velocity. Show that the greatest velocity during the 10 meters per second is, during the motion is 10 meters per second. He is asking us to prove that the greatest velocity and the displacements from A to from A of P and Q are same as when equal to 10. So what's that question? So what is that? Let us read the question carefully. A particle P is starting from rest. So initial velocity is 0 at a point A and travels in a straight line. Okay. Then comes to rest again after 10 seconds. The velocity time graph of P consists two straight line motions. A particle Q starts from rest. This is for P. This is for Q. A particle Q starts from rest at A at the same instant P and travels in the same straight line as P. The velocity of Q is given by, for Q it is 3t minus 0.3t square. The displacements of A from A of P and Q are same when t is equal to 10. So displacement of P should be equal to displacement of Q. That is the meaning of the question. So how should I find it out? Displacement of A and displacement of Q. Okay. So now displacement of P should be equal to displacement of Q when t is equal to 10. So for Q, the velocity is given as 3t minus 0.3t square. So if at all I want to find the displacement, I do the integration. 3t minus 0.3t square times dt. So displacement of Q is equal to 3t squared by 2 minus 0.3t cubed by 3 plus c. Okay, so now what, plus c. Let me write that c carefully. So it becomes, now I want to try to find the distance at 0 to 10. So at 10 seconds, because at 10 seconds, right? So I just substitute 10. So SQ at 10 will be equal to 3 upon 2 times 10 square minus 0.3 upon 3 times 10 cube. 10 cube. This is the distance traveled in 10. If at all I want to do minus between 0 to 10, I will do it out at the limits. Maybe I apply the limit 0 to 10 to make it easy to understand. 0 to 10 seconds. So in that case, I need not do the c value. So 0 to 10 minus 0 will be 0 minus 0. So this becomes 3 by 2 times 100. 1.5 times 100 is 150 minus 0 times 100 is 100. So 50 meters. So it has traveled 50 meters. So Q has traveled 50 meters, but in the question what has been given, SP is equal to SQ. So SQ is 50 meters, so SP also 50 meters. SP is in the form of a triangle, so area of a triangle is half base into height is equal to 50. Half base is again 10 seconds, which is the time, and height h is equal to 50. Height h instead of h, what I can do it is height is V. So I can consider height as V. So from there, 5v is equal to 50, so v is equal to 10 meters per second. So this is the greatest speed reached by p. Find the value of t in the interval 0 to 5 for which the acceleration of q is same as that of the acceleration of p. So first of all, 0 to 5 seconds. So this part, what is the acceleration of p? For acceleration of p, 0 to 5, initial velocity is 0, final velocity just now we got 10 meters per second, time is equal to 5 seconds, so I use v is equal to u plus at. From there 10 is equal to 0 plus 5a, a is equal to 2 meter per second square. So this only will be the acceleration of q2. Acceleration of q is also equal to 2 meter per second square. So I know the velocity of q is formula 0.3t minus 0.3t square, 3t minus 0.3t square. So if at all I want to know the acceleration, I do the derivative. 3t derivative is 3, this is becomes 0.6t. But acceleration is how much? 2 is equal to 3 minus 0.6t. So 0.6t is equal to 1. So from there t is equal to 1.67 seconds. That's going to be the answer. Finally, question number 7. Two light strings are attached to the block of mass 20 kg. The block is in equilibrium. horizontal surface AB, the strings make 60 degrees and 30 degrees on either side of the block. The tensions are T newtons and 75 newtons. Given that the surface is smooth, find the value of T and magnitude of the contact force. So what am I going to do? I am going to take first 75 newtons. 75 newtons is the green color one. I resolve this one into two directions. So this becomes 75 cos 30 and this becomes 75 sin 30. Similarly, I take T newtons. It becomes horizontal and vertical T cos 60 and T sin 60. Now because the particle is in equilibrium, so left side force should be equal to right side force. So left side force is T cos 60 should be equal to 75 cos 30. From there I get the value of T as 130 newtons. That is T. Now I need to know the magnitude of the contact force. What is the meaning of contact force? So there will be a contact force R which is acting upwards. That value is being asked. It is being balanced by its weight. Where is the weight? Weight is 20 G. So what are also upward force is equal to downward force because they are in equilibrium. So upward force is R and 75 sin 30 is upward force. T sin 60 is also upward force, whereas the downward force is just only 20 G. So R should be equal to 20 G minus 75 sin 30 minus 130 sin 60. From there R is equal to 15 newtons. That's it. Is there any eighth question? Nothing else. That's all. That's the answer for question number 7. So that completes the paper. CIE May June 2007. We won all the questions. See you in the next paper.